Section 7.3 deals with solving systems equations dealing with more than two unknowns. When you have equations with more than two unknowns, it's the easiest method to go about doing those is to use elimination to get the system to look like a set of three different equations, because that's what you'll have to start with. But in those three equations, one of them you would want to get it so it still has x, y, and z, or whatever the variables are, with some number in front of each of them, or maybe not any number in front of them, and it'd just be plain old x or y or z. And then, and this can also be plus and minus, a second equation you would want to have two of the variables, again with some other coefficients. And then finally you would want to have just one variable. And you do that by eliminating variables. Now it doesn't necessarily have to be z, that's the lone one. You could have x equals some number to start with. And then here you could have y plus z. Or x plus z, I should say. And then this would be x plus y plus z. And again, there would be coefficients with all of those. And you just have to work through them. It takes a little while. Last year, if you recall, we did this, and we did it in a matrix. Same concept, except here you'll keep the variables all the way through. So here's our first example, and we want to get rid of a variable. So we are going to pick two of them and combine them. And first we will take and multiply this one by a -5, because we're going to combine these two. When you multiply that by a -5, you get a -5x minus 10y plus 5z equals a -25. Adding those two equations together, the x's would go away. Then you would have a -18y plus 18z equals a -18. Now then, we need to try to eliminate another x variable, and so we would combine possibly those two and multiply now this one by a -3. When we multiply by a -3, we would get a -3x minus 6y plus 3z equals a -15. Keeping the first equation the same, and now adding those two things together, the x's again go away. That's a -9y plus 9z equals a -9. So now we have this equation and this one. And now we're just down to two equations with two variables. So I guess at this point, if you wanted to use substitution and go from there, you could. Or again, you can go by elimination, and let's see, we're going to get rid of the y's. So we're going to multiply this by a -2, and that way we will get y minus 18z equals 18. And so now we combine 0, 0, and 0. So therefore, we have infinite solutions, because that is a true statement. Now when you get something with infinite solutions, you need to figure some things out about it. And in this case, take any one of these two equations and say, got to pick out a new variable. Say z equals a. Because of one of these two equations, we know we have z or a y in there. So if we say z equals a, then we would have a negative 9y plus 9a equals negative 9. Solving for y then, you would subtract a negative 9y equals a negative 9a minus 9, dividing by a negative 9, y equals a plus 1. Now, why do you have to say z equals a? Well, you don't have to say z equals a. You just have to pick one of the variables that you're down to 2 with. Pick either one of them. You could have said y equals a, and then solve for z. Typically, though, you'll see all of them, they'll solve z for it. Set z equal to a. Now that we have what z is equal to and what y is equal to, we can substitute those into any one of these equations, and we're going to go with that one right there. X plus 2y minus z equals 5. And since z equals a, so it's minus a, and y equals a plus 1, we would get that. Distributing x plus 2a plus 2 minus a equals 5. To get x by itself, we have to move all of that, subtract 2a, subtract 2, add a, and you would get x equals minus a minus 3. And so then your answers would be x equals a negative a minus 3, y equals a plus 1, and z equals a. Now what that tells you is no matter what value you pick for a, then y is going to be, so let's say a is 10, then y would be 10 plus 1, which is 11, and then this would be a negative 10 and a negative 13. And there would be points in that plane. Moving on to the next question, trying to solve this one. First, because we have this and that, multiply this by a negative 1, so that's a negative x, a negative y, a positive z, and a negative 3, and combine it with that. The x's go away, the y's go away, and negative z equals 2. So then z equals negative 2. So we've already solved for z. Now you can substitute that into those equations. And so you have x plus y, and to begin with, it's minus, so then that would be plus 2 equals 3, and 2x minus y plus 2 equals 1. Simplifying these, you would get x plus y equals 1, and 2x minus y equals negative 1. And look at that. You already have a y and a negative y, so we can add them together to get 3x equals 0. So x equals 0. And then picking any one of the equations that we have, 1, 2, or 3, and we're going to go with 1, so it's 0 plus y plus 2 equals 3. And then solving this, subtract 2, and y is going to equal 1. So then our coordinate x is 0, y is 1, z is -2. And if you look at that on a coordinate grid, it would be 0, 1, -2. Now that's a 3 variable, so that's a 3-dimensional figure. It would be like the rooms, the walls in this room, and they meet in, say, the upper corner of the room. That point where you have a wall, and then this wall's coming out at you, and then here's the ceiling, and then that coordinate right there, which is part of this top of this. That would be the coordinate 0, 1, -2. Something like that. And those are how you're going to solve these equations. So those are the problems I would like you to try for tomorrow. 3 through 51, do the multiples of 3, and then also do these 4, which are story problems.